In this video, I will demonstrate how to use uniTank to do external settlement analysis. Here, I have a registered model of a tank that was scanned externally. I have estimated the diameter of the tank and set it in the toolbar. This is an important step because we will use this diameter to determine how many stations we need. Now, I am going to show only the data that is at the stations required for settlement analysis. Now, I am going to go station by station to estimate the projection plate elevations. You may want to turn up the point density on the display to see more data at each station. Just keep in mind that the full resolution data does not show up until you stop moving around for a few seconds. There are several ways I can add a projection plate definition. The first is to estimate it using the view center on the screen. Looking at a cross-section of data, I can judge where the best location of the projection plate is by toggling between side and top view. The second way I can use to estimate the projection plate elevation is to use the point tool. What I can do with this point is I can fit it to the closest plane. This method is more accurate. However, if the data is noisy or if multiple surfaces are detected, the point will not snap to the closest plane. You will want to make sure that the shell does not fall within the horizontal search distance. Otherwise, the point may be fitted to the shell instead of the projection plate. In some areas, the projection plate may not be visible. In these areas, you will need to unhide data around the station to find a more suitable location. You can also use the shortcuts Ctrl-P to fit the plane and Shift-P to add projection point to speed up the process. You will also notice that the station number is shown at the bottom of the window. You will want to be consistent in your estimation by placing the projection plate at approximately the same distance from shell at each station, and using the average point elevation or the highest point elevation. I will just keep going around the tank by hitting the next station button until I get back to the beginning again. Once I have added projection plate points to every station, I can run the settlement analysis. When you are setting your tank properties, make sure you identify whether your tank has a fixed roof, as this will affect the shell settlement tolerances. If the out-of-plane settlement exceeds the tolerance allowed, or if the R-squared value is less than 0.9, we need to run the secondary settlement analysis calculation. However, before we do that, I notice that there is a point in the profile that looks out of place. Let's take a note of the station number at this point and have a closer look. So it looks like that this point is located at an area of the tank where it is quite busy with piping. I'm going to look around to see if there's a location that better represents the projection plate. When I add the new projection plate point, I want to make sure that I delete the old one so that the settlement analysis uses the new station instead of the old one. Once we have repaired this point, I run the settlement analysis again. You can see that by repairing this point, we have improved the r-squared value of the analysis. Because r-squared is now at or above 0.9, we don't actually have to run the second method for shell settlement. However, I will demonstrate how to do this if your r-squared is still below 0.9. Looking at the graph, we want to take note of the peaks. Here, I see that the peaks on the graph are at about 270 degrees and 330 degrees. I will use these values and enter them into the shell settlement dialog when I run it again. When I run the analysis again, I get the results for the secondary settlement method. If you go to the output folder of the settlement analysis, you will find individual station plots. These cross-sections are good quality control metrics to ensure that the stations you placed or detected fit properly to the data.